Good evening. I'm Bob Hauser, Executive Officer of the American Philosophical Society, held at Philadelphia for promoting useful knowledge. Welcome to this, the first public lecture in our series for 2024. I'm glad that you've joined us this evening in spite of the frigid weather. I'm speaking to those of you who are really here. There are probably, I suspect there are many more who did not venture out tonight. But in any event, I welcome all of you, whether you've braved the cold to join us here in Benjamin Franklin Hall or have tuned in virtually. The American Philosophical Society acknowledges with respect that it resides in Lenapehoking, the homeland of the Lenape people, whose historical relationships with this land continue to today. We recognize their continued presence and perseverance despite centuries of land theft, removal, and persecution of their language and cultural traditions. Throughout its history, this society has benefited from its residents in this part of Lenape land, now called Philadelphia. We honor the Lenape community and those of other Native peoples through our collections, fellowships, research awards, our research center, the Center for Native and American and Indigenous Research, Native American and Indigenous Research, through our collections, fellowships, research awards, and other engagement activities. For those of you joining us for the first time, the American Philosophical Society was founded by Benjamin Franklin in 1743 at the suggestion of the botanist John Bartram, by the way, with the mission of promoting useful knowledge. Most of our nation's founders were members, and the APS had Thomas Jefferson as its president for 17 years, during most of which time he was either Secretary of State, Vice President, or President of the United States. Like the Constitution, the presidency, the Congress, and the courts, as a source and keeper of knowledge, the Society was an essential piece of the bedrock on which our new nation was founded almost 250 years ago. It remains so today. We'd like to think, at any rate. While we at the Society continue to admire Franklin and Jefferson and other founding members for their key roles in the formation of our nation, for their leadership of the Society, and for their devotion to science, education, and other noble causes, we are also much aware of their faults, most significantly their slaveholding. We at the APS are committed to sustaining the better parts of their legacies while working towards a future of inclusion, diversity, equity, and access, the APS idea. The Society is a catalyst for the discovery of new knowledge. Election to membership honors those who have made exceptionally significant contributions to science, the arts, and humanities, and to public life. The Society promotes research by providing close to $2 million. We used to say $1.5 million until recently, and then we counted. So it's close to $2 million a year in research grants and fellowships, primarily to the younger scholars who need the support the most. Our library and museum collections and research centers serve scholars and visitors from across the globe. And by the way, I might add that we now have 4 instead of 3 research centers. We have CNR, which I've already mentioned, and we have a Center for Digital Scholarship, and the David Center for the American Revolution, and our council just initiated a Center for the History of Science, which is really most important because that's the largest part and the most frequently accessed part of our collection, and somehow we never managed to do that before. The Society sustains and informs citizenry. We do that through our meetings, influencing the influences, and other activities like tonight's presentation. Having said all of that, I'm not going to introduce tonight's speaker, physicist Khachatur Manukyan. Rather, I am very pleased to cede the podium to Dr. Michelle McDonald, the American Philosophical Society's new director of the Library and Museum, who was appointed just this January 1st, actually maybe January 2nd, following a nationwide search. The director, or librarian in short, oversees the Library and Museum staff of more than 35 and stewards the Society's collections and the many scholarly activities connected with them. Professor McDonald brings not only great high-level administrative experience, but also an extensive background in museum education, a scholarly record in early American history, and significant work in public history. She holds a PhD in history from the University of Michigan, same place where I got my doctorate. It's not a bad, and they have a fairly good football team too. Some of you may have noticed that. Of course, we're the sorts of people who don't pay attention to those things. And she has an MA in Liberal Arts from St. John's College of Annapolis, a master's in Museum Studies and American Studies from George Washington University, and a bachelor's in History from UCLA. Dr. McDonald was most recently chair of the History Program and professor of Atlantic History at Stockton University of Galloway, New Jersey. In her 17 years at Stockton, she has variously held any number of positions of responsibility, including interim provost, chief academic officer of the academic city campus, vice president, and associate vice president for academic affairs. So I will now cede this handheld mic to my friend Michelle McDonald, and I hope you will welcome her warmly. This is her, so to speak, well, I'll say maiden appearance on the podium here at the APS.
Thank you. Thank you. Good. Oh, your wine. No, that's very important. Let's hold on. One moment. Transition.
This is,
Yeah, he'll give me the microphone. He won't give me the wine. It's important to have priorities. So good evening to all of you, and a very warm welcome on a very chilly evening to tonight's lecture. I applaud all of you for making it here in person, you intrepid academics and interested members of the general public. I even applaud all of those of you who are joining us virtually, because I realize there are any number of things you can do, and tonight you wanted to learn about colonial counterfeiting. So props to all of you. As Dr. Hauser noted, my name is Michelle McDonald. I am very pleased to be the new director of the Library and Museum at the American Philosophical Society. This is officially day 3. While I have lived in Philadelphia for nearly 2 decades, as you probably guessed from my academic pedigree, I come from the warmer climes of Southern California. My trip here was a little circuitous. For nearly a decade, I worked as a museum curator and educator. For another decade, I was a faculty member, very much interested in early American and Atlantic world trade, which is why tonight's topic for a business historian is of tremendous interest. And then for the last 8 years, I was a university administrator, working in the glorious world of such fascinating fields as assessment, accreditation. This is sarcasm, people. You can go ahead and laugh. It's all right. Zero-based budgeting. Anyone? No? You can feel free to ask me at a later event how enthralling those topics were, but let me reiterate how happy I am to be at the APS this evening. It is also my great pleasure to introduce tonight's speaker, Dr. Khachatur Manukyan, who will be discussing Benjamin Franklin's effort to combat colonial counterfeiting. Now, counterfeiting was a serious issue in early America because it undermined public faith in the economy, first of the empire and then of the nascent nation. So to ensure that what passed between the hands of buyers and sellers did so in good faith, Franklin sought to develop new printing methods and production measures to safeguard against duplicity. I look forward to learning more about these problems and about his creative solutions, and we will be doing so from someone in the know. Our speaker tonight is a research associate professor at the Nuclear Science Laboratory in the Department of Physics and Astronomy at the University of Notre Dame. He attained his PhD in physical chemistry at Yerevan State University in Armenia in 2006. And in 2010, he was awarded a Fulbright visiting scholar position at the Department of Chemical and Biomolecular Engineering at the University of Notre Dame, where he has continued his career ever since. He leads a team of researchers there, and his work tonight is based on the analysis of 600 paper notes printed between 1709 and 1790. This is especially timely for those of you who don't know, as tonight is the night we also celebrate Franklin's birthday. So please join me in welcoming tonight's presenter to the podium.
Okay, I hope you can hear me. Good evening. Thank you very much, first of all, to be here and for invitation. And this is really honored to be in this institution, one of the kind institution which established by Franklin. So it's a very odd combination to have a Armenian working in United States in nuclear science laboratory by training with chemistry and involved heavily in library objects and only connecting thing is scientific instruments. So how we come to this point, because when I started in physics department, we had a small program that they encouraged to train undergraduate students to do this type of research, usually in National Science Foundation when you get a grant, so you have to have a broader impact component of this, and that was the one. But over the time, I realized that we have an incredible collection at that library. So, and then Franklin name caught my eye, so we started about 7 years ago. Now we are at this point, so I will introduce this. And again, it's an honor to be on the day when Benjamin Franklin born. So I tried to find photos or stuff to depict the Benjamin Franklin birth, but you may imagine that 318 years ago, you would not find this type of stuff. This is AI, so it's a ChatGPT. I asked, can you create a photo? And it did pretty good. So this is the very day then Franklin born. So he was number 17 kid in his household. And youngest boy. There was also a younger sister. And he was 8 years old. Father sent him to, those are all AI. So father sent him to grammar school in Boston. And his intention was that young Ben would eventually become a clergy, but that never happened because he had no money to send him more than 2 years. It's ironically only 2 years of formal education. Franklin eventually became honorary degree holder from many colonial universities and also universities in Europe. So after these 2 years of study, he worked for a brief time for his father as a candle maker, but he didn't like it at all. And then his brother had this newspaper printing shop in Boston. He worked there. He really liked the idea. He liked the printing business. And during that time, about 5 years, he learned a lot, just reading books, because there was lots of stuff to read, and that was his formal kind of education when he started to explore the world. So then he had problems with his brother, And he wanted to run away from home. And in age of 17, he first went to New York, but it wasn't a good idea. And then he moved to Philadelphia. So you can see ChatGPT is making that image and even putting this modern skyscrapers here. That wasn't that time. Even you can notice here American flag. So this is how AI should improve, because that timeline there was no American flag. So, but he was young and very, ambitious. He came here, Philadelphia, and governor at that time noticed him, and he was young, very bright guy. He sent him London for 2 years to learn more about trade. The intention was that he will come back, and then Pennsylvania will have its own colonial printing house. But that never happened. He came back. Governor didn't kept his promise. Then he found this junto. I think it's a predecessor of American Philosophical Society. Am I correct? Yeah. So this is a club in English club style. So people gather together, discuss important things, they exchange ideas. And then breakthrough happened in 1728 when he was managed to buy a Gazette, Pennsylvania Gazette, and the printing shop. So how he managed, he partnered with wealthy guy, and then a few years later, this guy lost interest, and then he took everything. And this was pivotal time. We'll learn about this a little bit later. Next thing was founding the Library Company of Philadelphia. So you could see this is 1731. It was just beginning of his business. So there was shortage of books, and he were going to print many books. And he created this thing that, okay, not everybody needs to buy a book, but we can create this company which can buy and share. So this is common good, but also that was market for himself. So he was very cleverly utilized this idea that common good could be used also to enrich himself. So this is a pivotal time for people here. So 1743, he founded American Philosophical Society. This was, yes, this was one of the kind in American continent, I believe, not only here, but the entire Americas. And because he was already a scientist at that time. He was experimenting with the electricity and all these things. He was demonstrating experiments. He was doing these discussions. He created a some sort of bulletin. And eventually, the next venture for him was to found the Philadelphia College in 1749, and he became a first president. And this college eventually became University of Pennsylvania. So he's founder of many, many institutions here in Philadelphia. So overall, this very short historic overview tells that he had really very nice ability to pursue public, to engage in citizens in creation of practical solutions for common good, but while he was enriching himself. So this was his philosophy. Everybody benefited, but he's benefited too, financially. So now everybody know that Franklin's portrait is on a $100 bill. So when I was not involved with this research, I thought, oh, he's founding father of America. That's the reason, but of course that's the reason. He is one of the most influential founding fathers, but he was involved pretty much. He created American financial system, monetary system, colonial American, or helped create. So stepping a little bit back, so about money. What is money? So everybody knows what is money. Money is a medium that you can use to trade goods. So here's a very brief, how money developed. So there was barter, no money. They exchanged goods, and then there was this commodity money, and grain, salt, and stuff. Then it became more representative money. like metal shells, animal teeth, and eventually standardized coinage. And about 7th century AD, Chinese started to make some sort of paper money. But then Europeans pick it up a little bit later, and the first banknote that issued by England was 1694. And just after a year later, American colonies introduced, it wasn't note colonial, in some cases it was bank, promissory note, but that was first paper money. And after this, Franklin came, and then he influenced in this time. But of course, money evolved since then. We had later on plastic money we use now, and now we are moving to another cryptocurrency. So, and everything that you see here, problems, we are also encountering here now. So it's very interesting during these transitions. So again, this now, this will illustrate how he managed to do this. He managed people to get excited about something, but at the same time, he enriched himself.
Pamphlet on it entitled The Nature and Necessity of a Paper Currency. It was well received by the common people in general, but the rich men disliked it, for it increased and strengthened the clamor for more money, and they, happening to have no writers among them that were able to answer it, their opposition slackened, and the point was carried by a majority in the House. My friends there, who conceived I had been of some service, thought fit to reward me by employing me in printing the money, a very profitable job, and a great help to me. This was another advantage gained by my being able to write.
So yeah, this is just beginning of his business. 1 year later, when he established the business, in 1729, he wrote this anonymous pamphlet. He advocated this money created great good, because in that time there was shortage of coinage. There was trade wasn't not very good here around, and this would help people to, and the economic development in Philadelphia. But same time, he profited a lot. So, interestingly, he very early on he built this business network. So you can think of him like as a Jeff Bezos for modern time. So he had this advertisement, media, Gazette, he printed. There was lots of advertisements there. Then he was a postmaster. He was shipping and selling goods, very probably cheaply. And he was buyer and seller of lots of stuff. He was buying all of the printing stuff. He eventually became wholesaler of about 60-70% of printing business in colonial times. And he created all this network of printers at different colonies, mostly in Mid-Atlantic colonies here. So he trained them, sent them different places, his former workers, and then supplied presses, and then all of this stuff. And then he shared also 33% of revenue. So, but he managed to create this empire. He sold lots of stuff, not only this. And then he became very rich, but specifically for money-related stuff. So you could see here bullet points. He printed 2.5 million money notes for Delaware, New Jersey, Pennsylvania. And then eventually he partnered with this David Hall, and he semi-retired from printing business. And then when he finally retired, so this William Sellers came in, and these two guys continued the tradition. But the other printers also printed lots of continental money, colonial money in other colonies. But most importantly, in 1775, when Continental Congress introduced they started war during the Revolutionary War, they needed to finance war efforts. And they issued these new bills of credit, and Franklin and Adams at that time co-chaired the committee to oversee printing. And interestingly, Thomas Wilcox was a former partner of Franklin's, supplied a special paper, and then Hall and Sellers, they printed money. So he was founder, and he always advocated about paper money. So now, so what we did, we analyzed all of these artifacts in Hesburgh Library at Notre Dame. Some of you may recognize this mural. It's at Notre Dame. It's Touchdown Jesus. And by the way, Notre Dame has greater football team than Michigan. So So we used all these techniques, some of them X-ray based techniques, some of them electron microscopy techniques, some of them spectroscopy techniques, to analyze about 600 of them. So you could ask why we did that. So the answer is here. So it's interesting and fun. It started mainly as a hobby, but then we educated a great deal of students, and then it turns out that we also created some useful information, knowledge, as you like to say, for finding out new historic information and also for preservation of these unique artifacts. So now going back to meats and potatoes, so what he did. So very early on when he started printing money, he noticed that everyone started to copying. It was just paper and then printing. And he thought that he needed to come up with some ideas to prevent that happening. So his first idea was to imprint this, leaves of nature, leaf structure on the backside of money. So this called nature printing. So those are all different plants. And this wasn't a new idea. Leonardo da Vinci was doing this before, but only on a paper and a pencil and pen. He introduced a method to print this in a mass production. So nature printing. But this wasn't very successful. Eventually, people start to even copy these very intricate vein structures. Then the second one was misspelled some of the texts. So certain denominations he spelled differently. The idea was if they, alteration in bill value, then just this misspelling will tell that this was different money before. But that was not enough also. The next invention was, which is still now in the use in dollar, in many other currencies, is the introducing these threads and fibers, colored threads. So this is a bill. This is one of the famous bills, so printed in 1739. So you could see that's nature printed leaf. And you can also see very small fibers here. Eventually, the size become much larger. This is 0.1 millimeter. And even sometimes it becomes so large that it's covered large portions of the bill visibly. So this was another technique. And now we wanted to know what is this. So there was some historic knowledge that somehow he bought colored silk. And this is a bill, but later on, during the revolutionary time, printed by a guy who was his successor. And you could see here this large blue thread. And when we zoom in, we can see this X-ray image. This is the thread itself. And then when we did X-ray imaging, it turns out it contains calcium, sulfur, potassium. And interestingly, Raman spectroscopy, which is physics technique to use to understand structure of chemicals, so gives these peaks, which are all peaks coming from for the indigo. Indigo was and is still nice blue color pigment. So it's jeans color, it's indigo, synthetic one. But at that time in China specifically, when they extracted from leaves of the specific plant, they used ashes, burnt ashes. And this ash contained all of these elements, including calcium sulfate, which we also can see on Raman spectroscopy. So they used this color silk to introduce inside the paper. So you could see over the time, the colors appeared. Initially, it was just black, and then he introduced all these red colorant, and he introduced designs, specific designs that could be used to distinguish counterfeit and then real one. And eventually, after him, this becomes much more elaborate and nice, using the multiple colors. This Isaac Collins was his journeyman, and then he moved to New Jersey, and then worked with him on printing New Jersey money. Eventually, this was time when Franklin wasn't printing anymore, but he was using his techniques. So another very interesting thing that we find out, this was not known before, black ink contain very interesting material. So when we did the Raman spectroscopy, it gives a very interesting graphitic peaks. This is peaks for graphite. So when we did also imaging with silicon associated with ink, we also find out that there's other impurities. So this tells us that most likely he used a natural graphite, which was surprising because so he owned a separate print shop where he made carbon black, lamp black. To make carbon lamp black, you need to burn vegetable oils. This was very well known. He was selling that lamp black. He was using for printing other stuff. But Raman spectroscopy for lamp black is a little bit different. So we consistently see these peaks. So this is interesting finding because it's very difficult to imagine how they make ink out of graphite. So they need to ground it, disperse it. This is still, we don't understand how they managed to make it, but it's very consistent. It's always there. And another very interesting fact is that, so if you look here, this is a Massachusetts bill printed by Paul Revere, another famous American. So he was also a printer. You can see when we analyze this bill, and many others by him, so the ink contained calcium and phosphorus. So these colored, when we have intense coloring, so this says that we have more calcium in colors than it here. So we have calcium and phosphorus, and then this is a New Jersey bill, but it's fake one. Here also you can see it's these areas are calcium and phosphorus. So it means that these printers, both legitimate one and counterfeit printing people, so they used bond black. Bond black is the ink derived from pyrolyzing bone. So you put a bone in a closed vessel, heat it up for some time. Organic parts of bone became carbon materials, but it still contained 84% calcium and phosphorus. So that shows up in our analysis in X-ray imaging. Interestingly, he or his associate never used bond black. You cannot see them here. So this is his bill, and this is after his. So you can see there is really no calcium and phosphorus. So that also proves that it's exclusively he and his network used some different types of pigments. So what about these colors? A red color here, you could see it's associated mostly sulfur and the mercury. This was very well known, very famous red colorant, vermilion. It's appeared like many millennia ago, and it's been used up to 19th century. It was toxic material. It's very toxic material. That's why nobody is using. So we prove that it's there with this X-ray imaging. Also, Raman spectroscopy. Those peaks are vibrations, phonon vibrations of this material. So, but it was interesting that blue pigment was Prussian blue. So confirmed by both iron and also this spectroscopy of cyanide group. So it turns out that this is a hexacyanoferrite or Prussian blue. This was a synthetic pigment. It was first synthesized in 1605 in Germany, but it's made its way to American colonists and they use it. But most intriguing part was something inside paper money. So you could see one example. You will see if you look them, lots of these glassy type things. This is one of the large of them. It's 1 millimeter. So this scale bar is 1 millimeter. So you can imagine this is about 3 millimeter size. They're nice and flat, sitting on the surface. And when you tilt the bill, and then they glimmer, because if there's light, so they shine. So there was some historic literature about this. So they call it's a glass in the paper. Then we dig in the literature. There was an opinion in historians' historic publications that Franklin was heavily involved in developing a special type of paper specifically for printing money. But this is just assumption, because so he had a very secretive book of counts. He documented his spending, which actually lost. Nobody knows where is it now. In these years, he documented all spendings and the dealings with Anthony Newhouse, a paper maker. So historians presume that at that time he developed this special paper. Indeed, after this, in his real ledgers, when are public, so everybody can read, so you can see lots of entries. He's buying money paper from this paper maker. So then we wanted to know what is this. So we did this analysis which called X-ray diffraction. It's again X-ray technique, X-ray-based technique. So very early on, bills show only this pattern. So you see here this one, A, orange one. So you see a large peak, two small ones. This is very characteristic of cellulose. And cellulose is a main part of paper, so you see it. But then over time, new things are showing up. So these sharp peaks, and then even cellulose becomes smaller. So this is muscovite. It's a mineral which is a type of mica crystals. So then now we wanted to know, based on this analysis, we thought maybe we can confirm that it's really mica, because we didn't know it's just coming from paper, different type of paper, different parts of paper, or from these crystals. Then library allowed us to extract one or two small pieces, which is very rare. And we use a technique called focus ion beam milling. So this is not the same object, but imagine that this is a piece of that crystal. So, So what we do here, we deposit a very thin layer of platinum. This is all inside the microscope. And then you dig holes from both sides. So this scale bar is about 10 micrometers, 10 times thinner than human hair. And the idea is that you can eventually cut from here and take this small sample, make it even more thinner, and then look under different microscope to understand the atomic level crystalline structure of material. So you could see this is the process. It's much longer. It takes usually 4 hours to make a sample. This is a faster version of it. So the good thing is, if you have a historic object, if they allow to put, you cannot put the bill in the microscope because there is high vacuum involved, but they allowed us to extract small piece of sample. So then you can bring this type of wire and then weld it, the sample, and then eventually lift it out, and the rest of the material stays intact. Nobody even sees by eye that small piece cut. Then you lift it out and then transfer it to another sample holder. So this is, routinely done. Material scientists like everyday basis to create, and analyze materials. But these types of methods have not been used for conservation work. So this was first attempts to do this. Focus ion beam, and also later on transmission electron microscopy. So you could see that we breathe here, then we weld it on the grid, called the sample holder called grid, and the final stage is to thinning this down to make a less than 50 nanometer or about 50 nanometer. This is almost 100 times thinner than human hair. So this comes like this sample. The idea was to analyze or understand the chemical makeup and atomic structure of this. And it was disappointment. When we put this sample in the microscope, the high resolution microscope, it turns out that sample is damaging. It's very sensitive. So we call it radiation-induced amorphization or radiolysis. Electron beams, so you could see this large area of damage. It's just you don't see any structure. You still see some layer structures here, but it mostly damaged, the sample is damaged. Then we've got a very nice instrument. This is a $6 million microscope. So where this is the top of the line, one of the best in the world. So this one allowed us to image in very, very low electron dose rates. So we could have, make very small amount of electrons. It still eventually will damage some of the material. You could see here damaged areas, but very first scannings were intact, and then we've got very interesting material here. This turns out to be very nice. So you see here layer structure. So those layers, or here the magnified version here, and after image processing, these are potassium atoms. And those are silicon and aluminum and oxygen atoms. So we have layer structure, one potassium layer, silicon, aluminum, silicon, another potassium, and turns out that bonding between these layers are different, that literally you can peel off them and make it very thin samples. Ideally, you can even make atomically thin sample out of this material, so you can peel off. And they leverage this. So they managed to make a very, very flat, nice peeled off version, not very flat, but reasonably flat, to incorporate in the paper. So we did also this other analysis which called electron energy loss spectroscopy. This is an interesting and rare technique. It's used only in the microscopes. So that's confirmed that we have oxygen indeed, we have silicon and aluminum, but we saw we have some iron. It turns out that iron was substituting some of the aluminum. So after all of this, because those are very unique experiments, you cannot do much with these extracted samples, you don't have enough material, then we learned all of the chemical composition, and then we turned away and went back to a more traditional technique, X-ray fluorescence analysis. So here we analyzed silicon and aluminum amount and created the ratio of them and plotted over time. You can see these data points from 1754 to up to 1786. So, and those data points coming from different colonies. New Jersey money, Delaware, Continental dollar, Pennsylvania, and others. So they all have more or less same silicon and aluminum ratio. The same also here. So you see whenever you have multiple colonies printed in same time period, approximately iron to potassium ratios are the same. So this gives us an idea that it was coming from one geological origin. So, and indeed, Appalachian Mountains were close and still close. And even if you go to Chester County in Philadelphia, you will find still some of this muscovite stuff. So now the question was why they introduced this muscovite into the paper money. So we analyzed with paper money from Franklin's and his associates and compared with non-other printers. So what we see with this Fourier transform infrared spectroscopy here, that we see these peaks, which are based on kaolinite. The others are cellulose. They are similar in these cases and these cases. But for Franklin's paper, we don't have that kaolinite. Kaolinite it's still a mineral material which used to make paper in general robust and give a little bit bright color, shiny color. Because bleach wasn't invented at that time, paper was a kind of pale color. So we don't see that kaolinite. The first idea that maybe they introduced this mica instead to make it more mechanically robust and durable. And it's indeed, if you touch this paper, it's really hard. So they made a composite which is it's a cellulose and it's an inorganic layered material. This is the first type of composite that they created. Now, material scientists do these types of things routinely, but that like 300 years ago, 200 years ago, they did it without having this knowledge. So then another interesting thing came up. We systematically imaged them by X-rays. So first beels, they don't have these crystals. So, but then if you move on like 1755 and then later dates, you see these crystals both on top of the paper and also inside the paper. And interestingly, particle size are becoming larger and large, and they eventually become like very visible, like up to half centimeter. So for example, this one. So, and these flat ones are sticking on the surface. So we think that this was later on, they realized that they can leverage as a measure of anti-counterfeiting. So this is an example of fake bill, this one. You don't see that particles inside. But in real bill, so you see them, and there are many of them. So it's in a real, legitimate bill, you see these crystals. In counterfeit ones, you don't see it. So we now assume that, so he realized eventually that this is good for making robust paper, but that could be used also for differentiating fake from real one. But everything is changed when the Revolutionary War started. So British noticed that colonial paper money is helping economies, and they brought lots of fake materials from England. They brought here in New York, in occupied New York. They make really good fake money, and they distributed huge amounts. They flooded all of the colonies, this fake money. And then that brought to, it became worthless. Nobody even wanted to have this money. Even some people, they wanted to have, but they took it and then used it as a wallpaper. So this was the very first warfare tactic using in a state level to produce counterfeit money and distribute and then try to defeat enemy. Later on, this tactic used many times. Up to now, probably people using this during the wars. So, but this was first instance. So mostly those are the results that we found. This is about 7 years of work, and it was slow. Undergraduate students worked for a long time. We gathered data, and eventually we wrote a paper, and we published last summer in Proceedings of National Academy of Sciences. And we have 3-4 undergrad students here as a co-author. So it's just today, it's appeared as a free version, appeared online, so everybody can download. So you can just search the name, or there is a link. And research mostly funded by University of Notre Dame, and the laboratory where we do all of this stuff is funded by National Science Foundation. So this article generated very interesting, reviews from both newspapers. About 115 of them wrote, and some of them are very well-known ones, and even some scientific, very well-known journals highlighted about the paper itself. It caught eye also for international media. German broadcasters did an interview, and then French and Brazilian, Indian media paid good attention of this. But this is this is one part of this project, so one part of this program. So we have these two nice institutions at Notre Dame campus, library and Museum of Art. This is a brand new building. We had an older one. They just built this one and moved. We have incredibly large collections of lots of stuff. And so some of them are listed here. We have, for example, very rare medieval manuscripts. So we did a paper on this some time ago. But this is mostly done by undergraduate students. So, and many of them are not scientists. So they're art historians, medieval. So this lady is medieval specialist at Notre Dame Medieval Institute. They come and learn scientific techniques, and they use these techniques to analyze the historic materials. So during the COVID time, we managed to write a small book, textbook about the use of scientific techniques in cultural heritage objects investigations. So that's it, and I would like to thank you for privilege of your time to coming here in this weather, and the American Philosophical Society to give me opportunity to present our research. And this is from Notre Dame campus. You may know this Golden Dome and Virgin Mary on top of the Golden Dome. Thank you very much.
Yes, thank you very much for your presentation. The analysis that you conducted was to examine both fake and real paper money using rather elaborate and modern technology and equipment. So I don't quite understand how people 300 years ago could tell these differences. I must have missed something, but I don't quite get that.
Yeah, you're right. This is different time scale, and so when you look, for example, two bills like this Bond Black ink and Franklin's bill, the color is different. So they're both black, but Bond Black is a little bit lighter, and so eventually, many notes, when we now get it, there is a note there, it was counterfeit. And they realized that even that time. They didn't have this instrumentation, of course, but they had, for example, detectors, they called detector. Every banker or wealthy person had this detector provided by some authority. They know to compare, and some of them very well, by even eye, they could tell this is fake. Especially the ones that was early on. Eventually it becomes sophisticated until Revolutionary War. Whenever British came, they fake it really good. So yeah, you're right. And the interesting question is not only this. So those are 200, 250 years old objects, and they are aging all this time. We are not seeing what it was at that time. So that's also importance of this research. So we try to understand if something changes. So for example, there are researches, not ours, that people age cellulose and then try to understand how that ages. So that brings some also knowledge about conservation of these objects.
Oh, sorry, my apologies. And then we'll do you.
Does the American Philosophical Society have any of those bills in their library, I wonder, or their collection?
I think that's a question for people here, but I think, yeah.
We do have a few,
Day three again.
not 600.
Day three. We do have some currency. I know we do have some notes. I don't know what the extent of our collection is. Bob is looking at me going, that's a sufficient answer, Michelle. We can go from there. I can look into it. Sure. We had one question up here.
Was
I
there
don't
a
know,
specific genesis for the origin of the phrase "not worth a continental"?
So that's the reason when they faked it, British brought this fake stuff, it was then become really not worth. And that was very interesting because when United States become a country, so after Revolutionary War, Americans never wanted to have paper money anymore because of this bitter taste of, worthless paper money. And over next 60, 70 years, there was no even talk about making any paper money because that was progressed in Europe. They had paper money, but not here. They used coinage. But they came back during the Civil War when they needed to fund an army. At that time, Lincoln introduced paper money, which is similar to current days dollars. So it was greenish, and then it's evolved over time. So yeah, that's the reason. So it was worthless because of this enormous dumping of counterfeit money.
Yeah, I'm not sure. I want to respond to the earlier question. I'm not sure how much money paper money the APS has in its collection, but I know that the Library Company of Philadelphia has a very extensive collection of the paper money of that era.
So there is also, I think, largest one is in numismatic collection. There is a numismatic museum in New York.
Yeah.
They have the largest one. Then the Library Company, and I think Notre Dame is the third one. That's my knowledge. I may be wrong.
Okay, one and then one.
I was wondering how much was paper money accepted in the days of Benjamin Franklin among the public? As an analysis is how little accepted bitcoins are in our days.
So it depends who you ask. So some people make big money on bitcoins right now. Most of this money at the early on, there was not like money that we understand right now. So you go to do some service and they pay you some, it's a symbolic that they have to pay you back with later on with some sort of real money, coinage. The problem was that American colonies had always insufficient amount of coins. Mm-hmm. That was a British policy to drain as much as coinage from here as possible, not only from American colonies, but all of the colonies. And that was very, very scarce for coinage. And they promised, I will pay you back. Take this. It's a promissory note in some cases. There were 4 different money papers at the beginning. So there was bills of credit, promissory notes, and some other stuff. The same was happened during the Revolutionary War. That wasn't the real money. They say you go and fight, and one day we'll pay you real money. But people started to use it. They had that. They had no way to trade, so they give it somebody. The other one gave. It was used for trade eventually, but then it became worthless again.
You talked about the blue pigments, and I believe you use XPS to analyze it, and mentioned Prussian blue. There's another blue pigment called Turnbull's blue. Mm-hmm. Is your technique able to distinguish between the two?
We didn't see that pigment. It was mostly Prussian blue in the pigments, yes, and the indigo in the colored stuff. We didn't see that, no.
Hi, that's very interesting. I have a question. You mentioned the differences in minerals that were incorporated into paper. I think you mentioned kaolin, clay. Mm-hmm. Okay, in the production of paper, you have fibers in a slurry. And they didn't really have distilled water back then. It was impure water. That could have had sediment of clay.
Yes.
So and obviously the difference in paper quality would be dependent upon the source of your water and how pure. So was the introduction of these various minerals intentional to prevent counterfeiting, or was it just an accident of how you manufacture the paper at the time, what the source of your water was, which would have been a counterfeiting prevention anyhow, but I'm just curious.
Yes, so when they use a paper, made a paper not only for money, but you could understand that paper was a really dirty business at that time. So they use rocks, very worn out clothes. And actually when you looked Franklin's advertisement, he was buying these dirty rocks all over Philadelphia, saying, bring rocks. Then he was shipping this rock to the paper makers. And they fermented, it was becoming smelly stuff, and then they added this. Kaolinite was very common practice, even in Europe, before Americans start making paper. They mixed this ground kaolinite. It was adhesive to make it, gluing, giving it a solid content. But over the time, so it was, I think kaolinite still also ingredient in the paper. That is very highly likely when in a paper mill, somehow these crystals from water end up there, and they notice that, it becomes different. So then it's this one with these mica crystals, muscovites, they're really difficult to bend. It's really, really different than, we compared with a printed paper, Gazette. Gazette is completely different paper. It's much thinner. You could break it very easily, but this paper is thicker, more robust, it's very difficult. I think that was mostly unintentional. They observed it, and then they eventually observed, that's our hypothesis, we cannot tell for sure, that this not only gives a robustness, but could be leveraged for as a measure, additional measure.
Thank you for your presentation. This question is probably unfair to you, but someone in this room can probably answer it if you can't.
Yeah, sure.
The Continental soldiers were often paid with land warrants because of the absence of money. And so I wondered if there's any evidence that the British or others counterfeited those land warrants, which certainly had an enormous value at the end of the Revolutionary War.
That's I really don't know.
I just as a suggestion, I can say that the National Archives right now is doing a crowdsourcing transcription project on pension records for Revolutionary War soldiers. Most of those aren't run until the 1820s or 1830s, and they had to prove their service in order to earn that pension and access to funding. So there might be more details on that project.
I think we're at the end of our evening.
All right, last
one more. Okay.
last question for the evening.
Thank you. Thanks for the talk. The nature printing. Now, was the leaves and everything like that used as a template to put on engraved,
Yeah.
just as templates,
Yes.
basically?
Yes.
So, okay, that's
So,
basically
yeah,
the copper
he-
plates.
Yeah, copper plates, he made a way of engraving that in copper plates. And there is dispute. When we published this paper, somebody very furiously sent me email, oh, it's not his invention. But I say, okay, we are just saying other historians' stuff. We are not claiming that he printed, so nature printed. But this was, it's engraved on copper and then mass-produced.
Well, I hope you will all, you preempted me. I think this was a wonderful way to kick off our 2024 series to celebrate Franklin's birthday. And certainly it will be a memorable first lecture for me at the American Philosophical Society. So thank you very much.
Thank you.
I hope everyone enjoys their evening.